Hey everyone, welcome back. Today we're talking about something really fundamental when it comes to working with data modeling. Now, before your eyes glaze over, stick with me. This is way more important than it sounds. We're going to dive into why we bother with data modeling in the first place, what the benefits are, and the different ways you can approach modeling depending on what you're trying to achieve. Trust me, this is the kind of topic that may seem technical, but once you understand it, you'll see how crucial it is to getting anything useful out of your data. So, whether you're working in IT, managing data, or just interested in how all this works behind the scenes, this episode is for you. So, let's start with the basics. What is data modeling and why do we care? Well, to put it simply, data modeling is all about how we structure and organize data within a database or platform. Think about all the data that flows through a business: sales transactions, customer records, inventory, and so on. If you don't have a structure in place to organize all that information, it becomes nearly impossible to make sense of it. You'd have a giant mess of data with no clear relationships, no easy way to query it, and no reliable way to get any useful insights. So, data modeling gives us a way to impose structure on the chaos. It's kind of like taking a disorganized library with books scattered everywhere and organizing it into categories and shelves. Suddenly, you can find what you're looking for. You can see which books are related to one another and how they're connected. That's what a good data model does for a database. It makes it easy to understand, navigate, and extract meaningful insights from. But it's not just about making things look tidy. The choices you make in data modeling have serious implications for how your system performs, how scalable it is, and how easy it is to maintain over time. Okay, so now we know why it's important. But let's dig into what the actual benefits are. One of the biggest advantages of data modeling is data integrity. When you're dealing with databases, especially large ones, you don't want the same piece of information scattered across multiple places. If a customer's name or address changes, for example, you only want to update it once, otherwise, you run the risk of inconsistencies. This is where data models like normalization come into play. Normalization is all about breaking data down into smaller, more manageable tables and eliminating redundancy. There are different levels of normalization, and you might have heard terms like first normal form, 1NF, second normal form, 2NF, and third normal form, 3NF, tossed around. As you move from first normal form to third normal form, you're basically reducing redundancy further and further. In third normal form, every piece of data is stored in only one place. This not only improves data accuracy, but also makes it easier to update and maintain. It's a bit like organizing a warehouse. You don't want the same item stored in multiple places, otherwise keeping track of inventory would become a nightmare. By having a clear structure, you're also reducing the chances of making mistakes, which is huge when you're working with critical business data. But here's the thing. While normalization is great for ensuring data integrity, it's not always ideal for performance, particularly when you need to query data quickly. If your database is too normalized, you might find yourself having to join multiple tables just to run a simple query. That's where the trade-off comes in, and you have to think about what your priorities are. Do you need a system that's optimized for fast reads and queries, or do you need a system that's more optimized for writing and updating data? For analytical systems, where querying data is a top priority, we often move away from normalization and toward denormalization. This is where we intentionally add redundancy back into the database to make things faster. With denormalization, you're essentially saying, I care more about query performance than about storage efficiency. So instead of normalizing everything into small, distinct tables, you might group related data into fewer, larger tables. That way, you don't need to run complex joins to get the data you need for a report or dashboard. Denormalization is particularly useful in data warehouses, where the primary goal is to run analytics and generate insights quickly. We will get back to the podcast in just a second. This is just a note from me that if you want to learn how to get hands-on with data, you can find courses on Python, Apache Spark, and more at cody.co.uk. That brings us to different types of data models that are commonly used, particularly in analytics environments. One of the most popular is the star schema. Now, if you've ever seen a diagram of a star schema, you'll notice that it kind of looks like, well, a star, hence the name. At the center of the star is a fact table, which holds the metrics or quantitative data, things like sales figures, revenue, or transaction counts. Surrounding that fact table are dimension tables, which contain descriptive data that provides context, like customer information, product details, or time periods. The star schema is designed to make querying easy and efficient. Since the fact table contains all the important metrics and the dimension tables provide the context, you can write simple queries that pull the information you need without having to join a bunch of tables together. This makes it ideal for business intelligence and reporting systems, where you need to run lots of aggregations and summaries. And because the dimension tables are usually denormalized, you get the added benefit of faster reads. But there's another schema you might come across, the snowflake schema. This one's kind of like a more normalized version of the star schema. In a snowflake schema, the dimension tables are further broken down into subtables, making the model more normalized. While this can reduce storage space by eliminating redundancy, it also means more joins are required when you're querying the data. So again, it's a trade-off between storage efficiency and query performance. Snowflake schemas can be a good choice when you need a more structured and normalized approach, but you still have to weigh the impact on query times. All right, so we've covered normalization, denormalization, star schemas, and snowflake schemas. But let's switch gears a little and talk about a different kind of data modeling technique that's getting a lot of attention these days. Data vault. Data vault is a relatively new approach, especially compared to things like star and snowflake schemas, and it's designed with flexibility and scalability in mind. One of the big challenges with traditional models is that they can be difficult to change. Let's say your business evolves or you need to bring in a new data source. Making changes to a star schema or a heavily normalized model can be pretty disruptive. You might have to redesign tables, rethink relationships, and rework a lot of your queries. Data Vault addresses this issue by separating raw data from business logic. In a data vault, you break the data into three main components: hubs, links, and satellites. Hubs store the business keys like customer IDs or product codes. Links describe the relationships between those keys, and satellites store the descriptive attributes. This modular structure makes it much easier to scale and evolve the model over time. If you need to add a new data source or change something, you don't have to tear down your whole model. You can add new hubs, links, or satellites without impacting the existing structure. Another big advantage of Data Vault is its focus on auditability. Because the raw data is kept separate from the transformations and business logic, you can always trace your data back to its original source. This is super important for compliance, especially in industries like finance or healthcare, where there are strict regulations around data governance. Data Vault makes it easier to track changes to the data over time, so you can always show where a particular piece of data came from, how it was processed, and what transformations were applied. So Data Vault is great for flexibility, scalability, and auditability, but it comes with its own challenges. For one, it requires more upfront design work and planning compared to something like a star schema. It's also not as straightforward when it comes to querying the data because you're often working across multiple tables, hubs, links, and satellites. So you might need more complex queries to get the insights you need. That said, for organizations that are dealing with complex data environments or expect their data landscape to grow and change over time, Data Vault can be a really powerful approach. But wait, there's more. Data modeling doesn't just stop at how we organize data in relational databases. With the rise of big data and cloud platforms, new types of data modeling techniques are emerging that are designed to handle unstructured or semi-structured data. Traditional models like 3NF or star schemas work great when your data is well structured, but what happens when you're dealing with data that doesn't fit neatly into rows and columns? I'm talking about things like social media posts, log files, sensor data, or even images and videos. This is where NoSQL databases come in. Unlike traditional relational databases, which are built around predefined schemas, NoSQL databases offer more flexibility. They can handle different types of data, whether it's unstructured, semi-structured, or even fully structured. Instead of a fixed schema, NoSQL databases often use a schema on read approach, meaning the data doesn't have to conform to a specific structure when it's stored. Instead, the structure is applied when the data is read or queried. With NoSQL, you've got a range of different models to choose from. Document stores like MongoDB store data as JSON-like documents, making them ideal for semi-structured data. Column family stores like Cassandra are great for handling massive amounts of data that need to be written and read quickly. Key value stores like Redis are super fast and efficient when you just need to look up data based on a simple key. While these models don't replace traditional relational databases, they're an important part of the modern data landscape. Many organizations today use a combination of relational databases and NoSQL solutions, depending on the type of data they're working with. In some cases, you might even have a hybrid data model that combines structured and unstructured data to give you the best of both worlds. At the end of the day, data modeling is about making your data usable. It's about creating structures that make it easy to store, manage, and retrieve data efficiently. Whether you're using a highly normalized approach like 3NF, a denormalized star schema for fast queries, or a flexible data vault model for scalability, the goal is the same: to turn raw data into something that's organized, reliable, and actionable. And that's why we bother with data modeling, because it gives us a way to make sense of the vast amounts of data we work with and ensures that we can actually extract value from it. Without data modeling, you're just swimming in a sea of data with no structure, no relationships, and no easy way to find what you're looking for. So the next time someone asks why data modeling matters, you'll know exactly what to say. It's the foundation of everything we do with data.